alternative name, so don't worry, both are fine. This is basically the circular thingy we just seen in the animation. Okay? And if you look at the textbook, they are not actually having anything insulation, but they are more like having two rings. That's separate. That's why I call split ring. These are actually two words, split ring, two words. Separated so that it can serve the same purpose. Number two, you can see a sign. By the side of the split ring, you can see two rectangular thingy, and those are brushes. Those are brushes. It helps you to keep well contact. Not so special, but just something that keeps it smooth. And usually made of carbon, because you know carbon is conductive as well. This is the physically most conceptually difficult part. The turning effect is maximum when will you have the maximum turning effect? Turning effect means what? If you think about what you learned in year 9, when did you learn about turning effect? The top, very good. Or sometimes you call it moment. Remember? Moment in year 9, right? So you need to think about when is the force the greatest? Because moment is calculated by what? Force times distance. But here the distance is always the same. Why? Yeah, because the same radius, right? So you care more about the force right here. When it will be greatest, when it will be less. Think about this. When you are trying to have, for example, this motor, which is, I can't really see, but let's say horizontally like this. You can now remember one thing first. Trust me first. We said FBI, right? Force is the one generated. And what? Torque is the same word as moment. Yeah, turning effect. We said FBI, right? F dependent on B and I. So bigger B, of course, bigger F, or bigger current will give you a bigger force as well. Think about this. If you are trying to go through the B field, what you're doing is you're actually cutting through the B field. You are cutting the B field when you try to move around with it, right? So if you could cut more, that means you are changing the B field more. In that case, you have greater force. Because if you don't move, nothing happens, right? So you can think about whether when you are at the horizontal, I think maybe we are explaining another way. How about this? I think this is better. Let's say north and south. Can you draw this down as well? North and south. And let's say this is diagram A, case A, where you have, this is the front wheel. These are two wires, right? One must go in, one must go out. Yeah, for the current. So, how will this turn? Can you help me to use the left-hand rule to figure out what will happen to this wire? Down, is it? FBB is to the right, and I is
they're going towards you.
I is going in, so going down, right? Going down is correct. If this is going down, of course this must go up. Very good. So this turn in counterclockwise direction, right? Simple. In this case, think about this. If this wire keep turning, there must be a point where it go to the second case, B. When it keep turning, you can imagine this is the path. Right? So now, it will be like this. This move here, this move here, and while this move go up. Right? Does it make sense?
Yes.
And it's so far. Now, is the B field change?
No.
No, it's a current change.
Yeah.
Direction of current, is it the same?
No. Yes.
It's same. Yeah, it's the same. Right? Therefore, the force direction, is it the same? Must be the same. Sensible, right? You don't change B field, you don't change current, the force must be the same. It must be the same hand. If you don't change these two fingers, these fingers can't change. Now, this is the explanation. What is the force acting on this wire? I mean direction of force, sorry. Up, down, left, right. Look at the previous part. Down. This one. Up.
They cancel.
Do you see it now? This is a motor where the axle, do you know axle? Yeah? The like a stick that you need to turn. Rotate by about this stick, right? When you turn the motor. So let's say this is a coil. This is how it rotates. This is how it rotates. Right? This is how it rotates. But the thing is, we have got this power wire downward, this power wire going upward. And now if I go further, when it's vertical, B field is still the same, current is still the same, force must be the same. Let me ask you now, is A turning better or B turning better? Of course A. When you want to turn something, of course you have to push like this to turn. No one would turn like this. This is not turning. Do you know what I'm talking about? This is the axle it's fixed already. And when you want to turn something, you don't pull it downward. You push to the side. So B is actually the worst case. It's the worst time for the motor to move. So if you want to say the maximum torque that it experiences, it will be, yes, it will be the horizontal. So horizontal is correct. While vertical, it doesn't do much. Are you okay with that? I hope you can explain to me next lesson. Okay, I will ask some of you. Next sentence. You can see that I think I may not be the best to say no force when it's vertical. Vertical is basically this case, right? Vertical. This is the coil, right? But these are the main going in and going out current. Maybe I shouldn't say no force, but I change it to no what?
Energy.
No moment. Very good. You have force. It's going downward. But the thing is, this cannot give you any turning effect. Right? Just like you hang something, like a pendulum, for example. If you want to turn it, you have to push sideways. You can't pull it down. Pull it down doesn't swing this pendulum. So you don't have any moment when you are vertical. Are you okay with this? I would say this is the hardest part for motor. The rest should be quite easy. Let's have a look quickly. The turning effect can be increased by making more coils. Yes. Using stronger currents. I think current would. We won't say stronger current. We can say increase the current or greater current. So here, of course, I know what you mean by saying I increase. So I increase could be one of the answers here. At the same time, using a stronger what else?
Magnet.
Very good. Instead, I would like to put magnet. And that makes sense too, because if you use a weak magnet, or if you don't, yeah, very good, weaker B field, or think about this. If you don't even have B field, you don't have force. This is extreme. So the other extreme will be more B field, more force. So stronger magnet, of course. Number 3, increasing the numbers of turns. Same as this one. So instead of this, maybe we can put down increasing the current this time really. And lastly, you can, if you look at the task book, probably this one you need to look at the task book. Set, you can increase the area of the coil. Can I ask you, how come increasing the area of the coil will help?
More current to pass through.
More current to pass through. But let's say the current is the same. Let's say I draw you a picture. This one compare with this one. How come the lower one is better when you rotate? Okay, let's say it's not closer. Okay, closer is a good argument. Let's get rid of this. Okay, let's keep it more or less the same distance. But how come still bigger is better here? How come?
Stronger force.
Yes, this will give you a stronger force. This is better, but why? Lower resistance. Let's say resistance is the same, but still not about resistance. Sorry? Voltage. Not anything to do with current, voltage, and resistance. Think about physically about the B field. What's the difference in B field here?
It can affect more parts of the B field.
Say again.
It can affect more parts of the B field.
It can affect more parts of the B field. Very close. But maybe the wordings you need to change a little bit. Very close. You are not affecting the B field. It's the B field affecting you. Right? So think about this. For this one, girls, when you're rotating, at most you can draw this circle. Right? When you are rotating this thing. So you're actually using the B field within this area. How about this one? You rotate, you draw a circle like that big. You utilize the whole space. You utilize more B field. So actually you receive more B field. B field, when you talk about B field, of course it could be denser. Stronger magnet means denser. But if you can make a giant one, which you can experience B field, it will be useful as well. Lastly, it will also reverse the, if you want to reverse the direction of rotation, you can reverse current or reverse the force. This was not what I expect, because when we say reverse the rotation, of course you have to rotate the force. But anything else can we do?
The poles.
The pole of what? Magnet. Very good. Just like you switch the magnet, north to south and south to north. And you can reverse clockwise in any clockwise. Okay, keep. Can you cut this off?